it's done in the lecture. So therefore you should be able to catch it. Okay, so if you made errors on this part here, if you made errors on this part here, don't know how to solve the x and y from equality of two complex numbers, then you should review this example one more time. All right, so I need you to go over your homework. Okay, every time I graded your paper, you're supposed to go over that, and then whenever you made errors, you should, decide if you should redo it. If it's just simple calculation errors, it's okay. You don't have to redo it, and you just make sure that you don't make this error next time, or just make the corrections on your paper. But if you made conceptual errors like this one, okay, so if you solve this equation in a very weird way, then you should redo it and send back to me again. Just let me double check, see if you really understand this topic. Are you all listening to me? You're all listening to me, right? You know
Yes.
what I require.
Yeah.
Yeah.
So make sure that you do what I ask you, okay? So if you made errors, make sure you make corrections. And if the error is a significant error, it's a conceptual error, or if it's the understanding problem, then you should redo it and solve the problem one more time and then send back to me again. I'll be happy to look at it again and regrade it. Okay, so do not send me the entire set. Okay, just send me the correction part. All right, so today we're going to finish section 2.4. But before that, I'd like to take more questions. Anyone who has further questions?
No.
No one has questions. Did everybody turn in the homework? I don't think everybody turned in the homework yet, right? So many of you did, but some of you haven't. You need to turn in the homework as soon as you can. Okay, don't wait. Don't wait. Procrastinate. Okay. All right. So we're going to finish section 2.4. So recall in section 2.4 we introduced the complex numbers. So a complex number is a number of the form a plus bi, where the a and b are real numbers. Okay, I is the square root of -1 is a symbol. Okay, we don't know what that is. It's just symbol, such that we're assuming that it's a square equal to -1, because in the real numbers, there's no such a I there. So therefore the I is called the imagined number. And note, the square root of -3 can be rewritten as square root of 3 times I. But, okay, square root of -1 times -1 is not equal to square root of -1 times square root of -1. Okay, so don't apply the radical laws on the complex numbers. Okay, it's just this one is by definition. Okay, just so defined. So we introduced the set of complex numbers is denoted by this symbol C here. Okay, we write it as A plus BI, A, B are real numbers. So this means I collect all these possible collections, okay? Possible form of A plus BI. And it has, okay, so the question is are real numbers complex numbers? Question, are real numbers complex numbers?
Yes, because in
Yeah.
that case, the b coefficient would just be equivalent to 0.
So note that the real numbers are part of complex numbers, okay? And if an equation has no real number solutions, you say, okay, it must have complex number solutions, right? But but you should know that complex numbers also include the real numbers. Okay, so this is important. Okay, so this is the set of complex numbers. Now in complex numbers, we introduce the operations, addition and multiplication. So the addition of two complex numbers is just adding the corresponding components, a plus c and b plus d, then times I. And then difference is the subtracting here. Multiplication is a little bit complicated. You have to assume that the complex number has a distributive law, associative law, commutative law, in order to multiply them. And so therefore, in the end, you define this to be AC minus BD, then plus AD plus BCI. And that's how you multiply two complex numbers. And then using this definition, you can check that this implies that this implies that addition is commutative, associative. And this one implies that multiplication is commutative and associative. Okay. Associative. So it's very much like the real number system, but this number system is more general because there's I there. And then you can, you introduce the division of a complex number by another one. So division is done by rationalize the denominator because I is the square root of -1. So you want to rationalize this denominator. So you need to put the c minus the I here. Okay. And therefore you get, multiply the top, you get AC plus BD over C squared plus D squared. And then plus BC minus AD I over C squared plus D squared. Okay. So this is just in combination of the multiplication, the property of multiplication. Notice that we introduced the conjugation. So if Z is equal to A plus BI, we introduce that the conjugation is Z bar, which is the A minus BI. And such that Z times Z bar is equal to A squared plus B squared. And this is important. Okay, it's a very important property. For example, in some cases, you cannot factor certain things over the real numbers, but now you can factor over the complex numbers, right? So, like example, x squared plus y squared cannot be factored over the reals, right? But you can factor x squared plus y squared as x plus y times I and x minus y times I, okay? So now we can factor over complex numbers. Yes. And later on, we're going to show you that any polynomial in X can be factored over complex numbers like this. So there is a so-called fundamental theorem of algebra, says that any polynomial f of x, which is a n x to the nth power, and minus first power, a 1x plus a 0. So it's a polynomial over the complex numbers or real numbers, it doesn't matter. So it doesn't matter. Then can be written as follows: a n times x minus c1, x minus c2, x minus cn for some complex numbers. So in other words, you can always factor it over complex numbers. So this one will be done in chapter 4. Cannot be proved. We cannot prove this theorem. Okay, we're going to just discuss those in chapter 4. Okay. Now the reason we want to study complex numbers is because we want to solve equations. For example, if you want to solve x to the third power minus 125 or plus 125 equal to 0. So how do I solve this? Before we could solve this. We could solve x cubed equal to negative 125. We take the cubic roots and you get negative 5. Do you agree? That's the way we solve. But now it's wrong. Why it's wrong? Because you miss solutions over complex numbers. So x cubed plus 125 equal to 0 implies that x plus 5 times x squared minus 5x plus 25 equal to 0. Do you agree?
Yeah.
So therefore you get x equal to negative 5. And you could also have the second factor equal to 0. So you can use a quadratic formula to figure this out. 5 plus or minus square root of b squared 25 minus 4ac, which is minus 100 there. And this one you can simplify it as 75, so you get 5 plus minus 5 root 3 and I there, agree? Are you with me? Square root of negative 75 equal to square root of 75 times I, okay?
Yeah.
And 75 is 5 times square root 3, all right? So this is how you simplify it. So that means now you actually have 2 more zeros, even though they are complex numbers, okay? So make sure you solve it. So now this is considered to be wrong solution, okay? Because you missed the complex solutions. As I said, even though the I is an imagined number, but later on we're going to see that if you represent these complex numbers in the plan, in the complex plan, then it has a geometry in it. And therefore it applies to plan geometry even, trigonometry, physics, engineer, and everything. Okay? So the complex numbers becomes a very powerful concept. It applies to many, many practical situations. Amazing. All right, so we're gonna solve a few more equations here. So maybe we'll just do one more example. So let's solve this equation, which is a 5x squared plus 2x plus 1 equal to 0. And obviously, we cannot factor this. So to solve this, we use a quadratic formula. So solution is by quadratic formula. Okay, allow me to use QF. We have this x equal to half of 2 times 5, right? Negative 2, then plus or minus square root of b squared is 4, minus 4ac, which is 20, okay? So you get negative 16. Negative 16 is plus or minus 4i there, yes? And over 2 times 5. And therefore you cancel 2 out, you get 1/5 of negative 2 plus or minus, this is 1, sorry. 1, negative 1 plus or minus 2i, okay? And these are the solutions. So don't forget, using the zeros, you can actually factor this, okay? So note, using zeros, we can factor 5x squared plus 2x plus 1 as 5 times x minus the first 0. And then times x minus 1/5 of the second 0. Okay?
Wait, so Dr. Z, does
Yeah.
this imply that we can factor any polynomial in complex form?
I just said earlier that that's a fundamental theorems of algebra.
I see.
Yeah. So fundamental theorem of algebra says any polynomial can be factored into the x minus c1, x minus c2, x minus cn in general. So this one is in particularly very useful. Okay, so you can factor like this. And this one, so is it really, hold on. It seemed to be that there are some errors here. I have errors. Yeah, probably it's okay. So let's see if this is correct. Okay, so let's check on this. So don't try to multiply this out because it's too hard to multiply. Instead, so we check, okay, we check, see if this is really correct. So that's the thing. This one, you do this, you do x plus 1/5, then minus 2i over 5, agree? And then the second one, you write x
我
plus
靠，你要
1/5.
去大便啊！
Can
我要
you
再等一会儿。
can you mute yourself? Can you mute yourself? All right, so this one is x plus 1/5, then plus 2i over 5. Edward, why do I write this form?
Because usually you first write because usually you write it as a plus bi, so you would first write the real number and then the imaginary number.
Well, you see the points I want to check, see if this is true. In other words, I need to multiply this out. If you multiply this as is, it's difficult. But if you multiply this, it's easier. Why?
Because it's technically just like adding and subtracting fractions in that form.
And in this case, we can just when we multiply the product, we just get x plus 1/5 squared and then plus 2/5 squared.
The point is that this is a minus b form, this is a plus b form. Therefore, it's just different squares. And therefore, you get x plus 1/5 quantity squared. Now, the I squared is -1, so it's just plus 2 over 5 quantity squared. Do you agree? It's a lot easier. Instead of multiplying things out, you have to think. Here, you don't need to think. All right, so we get x squared plus 2/5 of x plus 1 over 25th. And the second one is 4 over 25th. And if you multiply 5 into this, you get a 5 squared plus 2x plus 1 there, agree? Which is correct, yes? So it's quite surprising that Remember that in the homework assignment, you're supposed to use the zeros to factor a trinomial. And people just solved the zeros without factoring. Then you just didn't read the questions carefully. Okay, so when you solve a problem, you need to read the instruction first, right? You should know that what is the final answer you wanted. And I do see people ignore that. Okay, so not so clear what you really want to do. Okay, you just imagine something you want to do, but that's not really what the answer is about. Okay, so now you can see it's quite useful. Okay, so now we're going to discuss something else. This is the problems in the homework, today's homework. That is, recall the definition. The complex conjugation, if z equal to a plus bi, then we define z bar to be equal to a minus bi is the complex conjugation of z. Okay. Do you agree? That's the complex conjugation. Like
Yes.
3 minus 2i. What is the conjugation of this? Tell me.
3 plus
3
2i.
plus 2i.
How about negative of 4i? What is the conjugation of 4i?
4i.
Negative 4i.
Try one more time.
It's
Somebody
just
said it
four-
correct.
It's
No.
just negative 4i.
Negative 4i, right? Because the I, anything in front of I has to be changing sign. How about negative 3i, conjugate of negative 3?
It's
Negative
just
3.
negative 3.
Yeah, so if it's a real number, it has to be, conjugation has to be itself. So here's the theorem. If z and w are complex numbers, then the following are true. One is that the conjugate of the sum equal to the sum of the conjugates. And two, the conjugate of the difference equal to the difference of the conjugates. The conjugate of the product, guess?
Yeah.
Maybe the product of the conjugates. Okay, so it's a very surprising actually. Number 4, the conjugate of the quotient equal to what? Surprising, surprising, surprising. It's the quotient of the conjugates. And then 5, if you conjugate something to the powers, then you can just take the power of the conjugates. So this one implies this, okay? 3 implies 5, right? Instead of just do 2 of those, you just do 3 of those, 4 of those, and you just keep going. Now the last one is, z is a real number if and only if the conjugate equal to itself. Okay, like this one, you see here. Do you agree? So this is a theorem, but it's listed as exercise in the homework assignment. But we're going to prove this in class, and you're going to prove the rest in the homework assignment. Is that okay?
Yes.
We're going to prove this too. And you have to see that how do you prove a theorem? Remember that you are now learning high school algebra, even though you are 6th or 7th grade, maybe, or 8th grade. But this is a high school algebra, which means that you're supposed to understand the subject in much depth. Okay, not the way you learned it from your school algebra 1. That's considered to be a joke. Okay, and you have to be able to tell everything about every single topic, every single calculation you do. You have to tell why that's the case. And you have to memorize the theorem the statement of the theorem. Edward, how many theorems you memorized you can state by this time? We have proved quite a few theorems.
The AMGM, the Pythagorean theorem, the
Well, you are talking about something out of the class. I'm talking about in this class, in algebra class. What are the theorems we learned? William, do you recall any theorems we learned?
I know we just learned the fundamental theorem of algebra.
That's
We
not,
also,
yeah, yes, very good, but that's not considered we learned yet. Okay, so we just forget about that. What else we learned?
We've also learned. I'm looking.
Yeah, I know, but you see the point that we don't usually try to memorize the theorems. Do you agree?
Yeah.
Yes, so that's not considered to be a good sign. So here are the theorems we learned. Okay, first of all, we learned this. We learned that the square root 2 is irrational, right? So that's one theorem. And the second theorem we learned is what? If A is less than B, then A plus C is less than B plus C. Do you agree?
yeah.
Then, yeah.
I think I know another one.
Yeah, A times C is less than B times C if C is positive. A times C is greater than B times C if C is less than 0. Agree?
Yeah. We also learned the zero factor theorem.
Yeah. What is the zero factor theorem?
If there are like two numbers P and Q, their product equals 0, then
Right.
either P equals 0 or Q equals 0.
Right. So this one is not considered to be a theorem. It's just a property of real numbers. Either this implies P or Q is equal to 0. Very good. Very good. So, but this is the real theorems we learned we proved in class. Okay. And then along with it, we proved a lot of other theorems like this. Like nth roots of AB equal to what? Nth roots of A times nth of B. If all radicals are defined, agree? Remember, this is the condition. Do you remember this? And then nth roots of A over B equal to nth roots of A over nth roots of B.
Nth root of B.
Mth roots of nth roots of A equal to nth roots of A. Agree?
Yeah.
So things like that. And we learned a lot of theorems, which we actually proved in class. We did prove this, okay? So you should recall how we proved them. And later on, you're gonna see a bunch of theorems, which we are going to learn and we're gonna prove. So every time I prove the theorem, you have to make sure that you can repeat the proof yourself. Like this one and this one we're gonna do, okay? So the proof of the first one is this. Remember that your definition of a conjugation has to be in the form of A plus BI. So we're going to let Z equal to A plus BI, W equal to C plus DI. Okay, if you don't write it in this form, then you don't know how to prove it because this is the definition of the conjugation. And Z plus W conjugate is equal to A plus BI, and then plus C plus DI conjugate. Why do I put the long line there?
Because we're taking the conjugate of the entire expression.
Right, so in this case, it says that you have to do the addition first. You cannot do the conjugation first because that's the theorem you're supposed to prove. If you do conjugation first, you just say the theorem is true, therefore it's true. Yes? So you don't prove anything if you do the conjugation first. So the long line says you have to do the addition first. To do the addition, you have to use the definition of addition, which is A plus C plus B plus D times I, and the conjugate. Now, do you know how to conjugate? A, B, C, D are real numbers. So this is real part, this is imaginary part. The conjugation is A plus C, then?
Minus B plus D I.
That's right. So now you get the, right? You get the, by the definition of a conjugation, you change the sign in front of I. It's only after you combine, after you add these two complex numbers, then you can use the definition. And now you're going to relate it to Z bar and the W. So you put A, B together. So it's A minus BI using the associative and the commutative law of addition. Then plus C minus DI, do you agree? And that's equal to Z bar plus W bar. Now, every single step is trivial. It's easy. But you see, if you don't show me these steps, I cannot really tell if you understand how to write a proof. Do you agree? So in other words, even though it is a simple theorem, it looks obvious. But if you really want to write a proof, decent proof there, you have to go through these seemingly trivial steps. If you don't do that, then you don't understand what you're doing. All right. So for example, now I want to see Rebecca. Can you help me on this? How do I prove this?
So you have to take the conjugate of like number 4 of the rules. You have to take the conjugate of Z over the conjugate of W.
No, I want to prove that. But how do I prove number 4? What should I do? How do I prove this equality here? So in other words, we're not rely just on teachers, right? We try to do things ourselves, yes? How am I going to prove this as a theorem? We don't know why this is true.
First we can let Z equal A plus BI, and then we can let W equal C plus DI. And then we can simplify this by multiplying this fraction by C minus DI and over C minus DI. And then the bottom will become C squared plus D squared, while the top will simply become the product
AC plus BD
and
BD,
then
right?
plus, yes.
And then plus BC minus AD. Let's write this as two parts, okay?
Yeah.
So it's plus BC minus AD over C squared plus D squared I. Now, can you all do this? Can we all do this step? Envy, can you do this step?
Yeah.
Do you understand this step?
Yes.
You do? Very good, very good. Let's see who else here. I want to see everybody. Okay, Audie, do you understand this step? Audie, are you there?
Yes.
Okay, can you do that step? Do you think that step is easy? Yes or no? It's just ask a question. Audie, are you there? What happened? You cannot answer questions? Oma, does that make sense to you, this step? Hello, Oma, are you there? Vishwa, are you there?
Yeah.
Josh? Yeah. Do you understand that step?
Yeah, I understand it.
You understand it? You know how to multiply this, right? You know how I get this, right?
Yes.
And then this one.
Yes.
So, okay. Now, how do I conjugate this whole thing? Is that Yash? If I conjugate the whole thing, how do I conjugate this?
You replace the addition sign in the middle of the expression with a subtraction
Right,
sign.
so the conjugation, because now it's in the form of x plus yi, if you conjugate this, it's just changing the sign in front of I, agree?
Yes.
So therefore, this is equal to what? Equal to, instead of plus here, you subtract, agree? So that's after the conjugation here, after this conjugation. Then, Rebecca, what should I do next? Can you hear me, Rebecca?
Yeah. After that, do you just I'm not.
That's okay. It's completely fine. I mean, you don't have to, know everything. I'm just curious. Okay, so Jennifer, do you know what should I do next? I checked this equal to this. What do I do next? What should I do next?
I'm not sure.
Okay, so Edward, what do I do next?
You simplify the conjugate of z over conjugate of w.
That's right. So we also, you see, we did this calculation on this part here. And now we have to do the other side to see if they are equal, agree? And let's do the conjugate of z over conjugate of the w. And that's equal to a minus bi over c minus di, right? How do I simplify this, Edward?
Multiply by c plus di on the numerator and denominator.
And so the bottom is still c squared plus what? E squared, right? The top, you look at the real part, which is a times c, then negative bi times di, give you ac
plus bd.
bd. How about the imaginary part then? Well, you do a times d, right? Ad, then b
AD
times
minus
c
BC.
minus bc. Are they equal? Are these two
Yeah.
equal? They are, yes. And then we checked because the negative sign can be, put into the numerator, right? Then you can change the sign, becomes AD minus BC. So they do equal, yes? So this implies what? This implies that, this two implies that Z over W, the conjugate, equal to Z bar over W bar there, okay? You do this one, and you do this one, and you do this one, you do the last one, okay? In the homework assignment, right? All right, so now I'm curious. Are you all using the addition 12, or are you all using the addition 11? Which one you are using when you do the homework?
I'm using the 12 addition.
11.
I'm sorry?
I have 11.
I have 11 too.
Anyone else? Are you all using 11?
I have 12.
You are using 12. Okay, so I'm going to make sure that when you do the homework, make sure you use the right addition. Okay, I will put the assignment for both 11th and the 12th edition. If I do not say anything, that means these two books should have the same assignment. All right. If I do indicate that for the 12th edition you have a different set, you have to do the set I assign. Okay. Do not mix the 11th and the 12th edition, because the problem I assign are the very basic minimum assignment. If you do a wrong set of problems, then you will not practice on the part which I lectured. Okay, this is section 2.4, and we are done with section 2.4 now. So section 2.5 is about solving equations. The first equation we want to solve is so the first equation I want to solve is this. Epsilon of x minus 7 equal to 3. So how do I solve this equation? Anyone?
You
If
do
you want
x
to-
minus 7 equals 3 and x minus 7 equals negative 3.
That's right. So this one is equivalent to x minus 7 equal to plus or minus 3, okay? And therefore, you get x equal to 7 plus or minus 3. And you have two solutions. One is 10, the other one is 4. No need to check, do you agree? No need to check is that there's no problem of definitions. As you can see, every x here, both sides are defined, okay? So there is no domain issue here. Now, how about this one? How do you solve this one? X minus 7 equal to negative 3. How do I solve this one?
You can set two conditions. One where x minus 7 equals. Wait.
It's
This
impossible.
case would be under.
No solution.
Right. So this one you have to, when you solve equations like this, you have to think. Okay. So this is, you cannot do this anymore. Okay. So this is false. So this one you observe. No solution. Why? Why there's no solution? Well, because absolute value is always what? Greater than or equal to 0. Since absolute of x minus 7 is always greater than or equal to 0. It's never going to be negative 3. All right, that's important. And the next one is, how about this one? How do I solve this kind of equation then? I have 4 terms. What should I do?
You can factor.
Yeah, you have the factor. What's the technique to factor this?
Grouping.
Grouping, very good. Factor by grouping, so which is x squared, x plus 2, minus x plus 3, right? The quantity of x plus 2 equal to 0. And then you can factor x plus 2 out, and you get x squared minus 1 equal to 0.
So it's
Yeah, x equal to negative 2 or plus or minus
1 plus minus 1.
Right. So these are the solutions, okay? All right, so how about this one? X to the 3/2 equal to x to the 1/2. Solve this for me, Edward.
Multiply by x equals 1/2.
Okay, then you get x squared equal to x, right?
Yeah.
Yes.
And you split it into 2 cases if x is equal to 0 or
No,
x.
no, don't do that. Yes, I know you are doing that. You are good. Okay, that's how you solve it. But do the way which I teach you. Move all terms to what?
To the left.
Yeah, move all terms to
One side.
yeah, one side. Okay, you can discuss, but there's really no need to do that. Okay, you have a more complicated equations when you discuss cases. You have a lot of cases to discuss. Move everything to one side. You get what? You get a 0 on the other side. Then do what?
You can factor x.
Yep. Then factor. Don't forget, solving equations are all about the factoring. Okay, so you get this. And therefore, you get x equal to 0 or 1 there, okay? Make sense? Otherwise, you're fine, okay? If you discuss x equal to 0 or x is not equal to 0, then you can cancel x out, right? But we just make it more straightforward here, okay? You can do whatever you want to, But as a teacher in class, I would teach this standard way to solve. Okay, you are always welcome to invent your own method as long as it's correct. All right, so the other example. So here is a good example. Okay, so let's take cubic root of x squared minus 1 equal to 2. How do I solve this equation?
You can cube the two sides.
That's right. If you want to move 2 to one side, 2 to the same side, then you don't actually, you are not able to factor, right? So you have to clear the radical first. Like a radical is like a black box here. Cubic roots of something is a black box. You cannot really see things. You have to open the box. So open the box, you get x squared minus 1 equal to 8, okay? Then you get x squared equal to 9. And this time you don't need to move to one side because we know how to solve this. X equal to plus or minus 3 there, okay? That's how you solve it. And next problem is a little bit, tricky. Yes, Yash, any question?
I have a chess tournament at 11, so I have to leave.
That's fine. You can always go to the video, okay? Check on the video. But today is you're gonna miss a lot because of.
Yeah, I'll watch the video.
All right. So, so in this case, what we do is what? What do I do?
We can move 3 to the right side, and then we square the two sides.
That's right. So because remember that the square root is a black box, you have to clear the square root in order to see the inside here. So we have 3x plus 1 equal to x minus 3 squared. And then you get x squared minus 6x, then minus this is minus a total of. Let me do 2 steps, sorry. I'm a little bit kind of jumping ahead. So now we can move everything to one side, okay? Remember that that's the general rule of solving equations, moving everything to one side, then factor. If you move the radical to one side, then you cannot factor it. So you have to clear the radical first before you do the rest. Then you get x squared minus 9x, then plus 8 equal to 0. And now we can factor x minus 1 times x minus 8 equal to 0. You get x equal to 1 or x equal to 8. Edward, is this correct?
Yeah.
Yeah. How about you? Jennifer, is this correct solution? Jennifer, do you want to talk to us in class? No? Rebecca, you want to talk?
Yeah, it makes sense.
Makes sense. But if I tell you this is
x equals 1 doesn't work.
Why?
Because if we plug in x equals 1 into the given equation, we get something like 3 plus 2 equals 1.
So, but my algebra is all correct. Why do I get this extra so-called extraneous solution there? What happened? All my algebra is correct, right? All the steps are correct. Edward, can you tell?
Is it?
I think. Yes.
Is it?
Go ahead.
Is it because for the second step, if you plug in 1 for the second step, root 4 equals -2.
Right. But you see, my algebra is correct, right?
Yeah.
If my algebra is correct, how come I actually change a non-equality into equality?
Is it because when you square it, you're also considering the negative version?
That's right, yes.
Oh,
Is 1 equal to -1?
no.
Oh.
But if you square it, they do equal, okay? So in other words, if you squared both sides, that means you could create what? Extraneous solution, because you could create things like this. Do you agree? Y is not equal to -1, but when you square it, they could be equal. So the solution you get is it's a solution of the a squared equal to b squared, not a equal to b. Okay, so that's where you create it. Do you understand this course now? We're not just trying to solve it. We're not just trying to say, okay, we need to check. But why do you need to check? How come we get this actual extraneous solution? That's all because this reason, okay? Just like in the fractional equation, we could create the extraneous solution when you multiply the common factors, common denominator to both sides. Do you agree? In that case, you have to make sure denominator is non-zero. Otherwise, right, this is undefined. So that's the reason it creates this extraneous solution. Okay. Okay, let's try another one. Now this one is 2x minus 3 minus square root of x plus 7 plus 2 equal to 0. And so we moved everything to one side. Then what can I do from here? Even though I moved everything to one side, but I cannot do anything, right? So therefore, what should I do?
Move square root of x plus 7 and to the right side, and also move 2 to the right side.
Yeah, you don't have to do both of them. You could just do one of them. But in any case, your goal is to clear the square root, okay? So now what do? We can square both sides, okay? Square both sides, you get this. Now, people always square like this, x plus 7 minus 4. Is this correct?
No.
Plus 4.
Plus 4, is this correct?
No, because we also need to subtract 4 times
Right.
root.
Now, can I just make, I want to do it very slowly here, okay? A minus B. When you do this, let's just square root of this. What is this square? Is this equal to A minus B?
No.
No. What should this be equal to? You use the formula, the x squared minus twice of x and y, then plus the y squared. Do you agree? So can you guys make sure that you don't make this error? Okay, so every single time I see tons of students making this error, I would say that this is like when you learn the school algebra, it's like infected by virus. So the virus is always in your brain. So people always do this, you know, always wish this is true. Always wish this to be true. Never, okay? So this is the middle term. You got to be clear. You have to have the middle term there. Okay, did I say enough here? Did I say enough on this thing here? Warn you enough so that you will not ever make this error, right? All right, so let's keep going. And if you made this error, next time we're going to ha 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 to you, okay? So what is this middle term, tell me?
Minus 4 root x plus 7 and plus 4.
Very good. Yes, so this is the part people always forget. Okay, now what should I do?
You can isolate the square root.
Yeah, again, we have another square root, we have to isolate it. So you move everything to the other side, so you get x. 11, so it's negative 14, yes? You agree? Are you with me?
Yeah.
We subtract x from both sides. We subtract 11 from both sides. Now we can square both sides again. And when you square this side, you get x squared minus 28x plus what?
196.
196, right? And this side becomes?
16 times the quantity of x plus 7.
Very good, thank you. So now let's move to one side one more time. So it's gonna be 44x.
Plus 80.
112, right? 112,196. So it's 208, right? No. So this should be
supposed to
3.
subtract 100.
Oh, I'm sorry. It should be subtract. Sorry. I made errors. Okay, so it's gonna be 196 minus 112. It's gonna be 84, right? Thank you.
Negative 84. No, it's just 84.
Now you could use a quadratic formula. In this case, probably you should factor, right? How do I factor this? 2 and 42, do you agree? And then you need to both be negative, yes? So you get x equal to 2 or x equal to 42, do you agree? Let me factor this first before I solve this, okay? So this one is x minus 2 times x minus 42. Product equal to 0. So you got x equal to 2 or 42. You agree?
X equals 42 is extraneous.
Right. If you put x equal to 2, you get a 1 here. This is good, right? 42. For the 42, you get 9 equal to 7 minus 2, which is not correct, all right? Hold on. Yeah, so 9, 49 is 7 minus 2, which is not correct. So this is not correct, okay? And therefore, we need to check. So check x equal to 2 is the solution, okay? That's the final solution you have. All right, so now we know how to solve these kind of equations, and let's look at the other type. X to the 2/3 plus x to the 1/3 minus 6 equals 0. How do I solve this one? Do you want to clear the cubic roots?
You could set a new variable to x1 to the 1/3 power.
Right. Because if you clear the cubic roots, then you're going to be stuck in on this. If you take the cubic power here, you would get 6 minus x to the 3rd to the cubic power, which is so complicated, right? Complicated. You are making a equations what? More complicated than before. So don't do this. This is wrong step. Instead, we're going to set a new variable called u equal to x to the 1/3. Then u squared would be equal to x to the 2/3, okay? Therefore, the equation becomes u squared plus u minus 6 equal to 0, and you get u plus 3 times u minus 2 equal to 0. You get u equal to -3 or u equal to 2, okay? But u equal to x to the 3rd. And then you take the, yeah, go ahead.
So since for a solution that says u equals -3, since that represents x to the 1/3 power, it would be x equals -27. And for the solution that says u equals 2, since that also represents x to the 1/3 power, that would be x equals 8.
So this is how you solve this kind of problems. Make sense? So in other words, you are setting a intermediate value, intermediate variable, okay, called u sub here, or the
Dr. Z, I can't hear you.
Me neither.
I think he froze.
I think his Zoom crashed.
Yeah, the screen just froze.
Yeah. It says he's still in the Zoom though. Oh yeah, his Zoom crashed.
That's
He's
weird.
out of the meeting. What do we do now?
He should be back soon.
I think we should just wait.
Let's take a look at example A. I think that's what he'll be discussing next.
How is he still not here?
I think his Wi-Fi like crashed entirely. That's probably the reason why he can't join back.
Should someone send him an email?
I mean, if his Wi-Fi is not working, I don't think he can check his email either. But I guess I'll try. I mean,
Try to send him like an invite.
Oh, yeah.
Wait, does anyone know Dr. G's phone number? Because we could just phone him and see what happened.
No.
I don't know what that is.
Hello.
Hi.
Hi.
Yeah, can you hear me?
Yep.
Yes.
Yes.
Free now.
Yeah, very sorry that my internet is completely dropping off. So let me see what can I do. Okay, so Now, the equation we have, we only have about 30 minutes left. Okay, so the equation, my internet could still be a problem. Okay, so you guys have to be prepared for this. And in case we really have issues, we can just change. We have additional 30 minutes class. In case we have issues, we can just find a different time to do to make it up. Okay. So the equation we had here, this equation now can be solved using an intermediate variable. We set u equal to x to the 1/3. Now we change this into a equation involved with u is quadratic. So this kind of equation here is called quadratic type. So it's not a quadratic equation, but it's a quadratic type. Okay. So this equation is of a quadratic type. All right. Let's do another example like this, which is x to the 4, then minus 3x squared plus 1 equal to 0. And then in this case, what will be u? Tell me.
X squared.
X squared.
Yeah, we said u equal to x squared. Then you get u squared minus 3u plus 1 equal to 0. And then you get u equal to 3 plus or minus square root of b squared minus c, which is 5. And then don't forget u equal to x squared. And therefore you get x equal to plus or minus. Don't forget, okay, when you take square root, there's always a plus or minus there, half of 3 plus or minus root 5. Okay. Now, there are 4 solutions. In the book, it tells you these 4 solutions. But if you do math counts and if you write your solution like this is a wrong solution. Edward, why?
Because there's a square root and a square root.
Right. So why? So what would be the correct way to solve them? Well, William, do you know? You?
First, I guess we need to rationalize the denominator.
Okay, so we do that. So you get a 6 plus or minus 2 root 5, right? Then?
We need to find some way to factor the square root inside
Right,
some
yes.
squares.
Yes, actually, you see this is a 2 times square root of 5, can be thought of as 2 times 1 times square root of 5. So it's like the complete square, the middle terms of 1 and 5. So it's going to be 1 plus or minus square root of 5 quantity squared. Do you agree? Check this out. Because 6 is 1 plus 5. And middle term is 2 times 1 times square root of 5. And therefore, this is equal to plus or minus 1/2 of what? Tell me.
1 plus minus square root 5.
Well, you'd better do it right.
Absolute value.
Yeah, it's absolute value. So it has to be positive. You have to do the other way around. Even though in this case, it really doesn't matter. But you need to be careful, okay? So you have basically 4 solutions there, right? So this is the bottom is, yeah. So this is a correct solution. And this one is incorrect solution, okay? So don't make errors on this. It's called rationalize the denominator. And then you need to complete the square inside of the square root. And that's the key. All right, make sense to you? Square root of 1 plus 2x squared. And then actually, let's do this. 2x squared. Then I say, let me do this. Right, so this is a 1 2x squared and minus 1 over so 8x squared. How do I simplify this? Well, you can write this as a 1 plus 4x to the 4, yes? Then minus what? Hello? Minus?
A half.
1/2 plus 1 over
1.
8x squared, agree?
Yeah.
But if you have a 1 there, extra 1 there, so it's going to be square root of 4x to the 4 plus 1/2 now. Plus 1 over 8x squared. What is this? 2x squared plus 1 over this, okay? And that'll give you 2x squared plus 1 over 8x squared. You see the point here? So you know, sometimes inside the square root, you can complete square. Then you can clear the square root. Do you agree? Are you with me on this?
Yes.
Yeah.
Yes.
So the point is that you can complete the square inside of square root sometime, not always, okay? All right, so for example, like a square root of 2 minus square 2, nothing you can do, right? So you cannot do anything. Okay, so we have one more example to go, then we are done with this section. Now, example 9 here. So let's determine the root of a ferry. This is the town, this is the island. Here is this is 3 miles. Okay, so you want to have a ferry going from the town into this island. There's several ways you can do. You can just directly rowing ferry to that, or you can go along the shoreline, then go to here, okay? The trouble that you don't want to go into the ocean right away is because in the ocean, your speed is very slow. It's 10 miles per hour. If you go along the shoreline, it's 12 miles per hour. So if you want to save time, sometimes you should do this way. And then this is 10 miles per hour, okay? Now the question is, where should I turn so that the total trip, right? Total trip takes 45 minutes. Does it make sense to you?
Yeah.
Yep.
Okay. So you tell me what should I do? Well, maybe you should just use this point as the origin, right? And to say that somewhere you turn called x there. So we let x to be number of miles on the shore line from the town for the ferry to change route, right? How do you spell ferry? Just this, ferry to change course, okay? Does that make sense to you? You see, every single time I solve equations, I solve problems, I need to set a unknown. So this is your x. And now you need what? You need a equation there. So you want the total ferry to take 45 minutes, right? So therefore, your equation is about what? The time, you agree? 45 minutes, yes? So how do I do 45 minutes here? Tell me.
We use the formula time equals distance divided by speed.
Or rather say that, yeah, the distance is equal to the time times the speed, agree? Which means time is equal to distance divided by the speed. So what do I do? If you go along the shoreline, it's 12 miles per hour. So it's gonna be
it's going to be x over 12.
then
And then plus
this part of the distance is what? So you need to use the right triangle here, right? It's a Pythagorean theorem. So this part is, oh, I see, I'm sorry. So this is a total of this is 7 miles, okay? Along the shoreline, total of 7 miles. So this is 7 minus x, do you agree? So it's the square root of 7 minus x, quantity squared, then plus 9, divided by 12, 10. Is that correct?
yes.
And what? Is this correct equation?
Yeah.
No. Because these are miles per hour and this is 45 minutes. So obviously you are using wrong units. Agree?
Oh,
So we should have what?
3/4.
Yeah, 3/4 hour here. Agree? And that's how I solve it. Okay. Now after I solve this, after I have this equation, okay, so you understand how I build this equation, right? This is the time used along the shoreline. This is the time I used in the ocean. So therefore, you need to clear the denominator, which is 60. So you get 45 equal to 5 times x plus 6 times square root of 7 minus x quantity squared plus 9. Okay? And then you need to clear this. So you get 45 minus 5x equal to 6 times this. And then square both sides. Square both sides, so you know how to square this, right? 45 squared is 20 what? 25 minus 2ab, right? Which is 450x plus 25x squared equal to 36. Then this guy squared, so you get x squared minus 14x plus 49 plus 8, which is 58. 49 plus 9 is 58. And you simplify from, simplify this equation, you get 36 x squared. Allow me to just give you the answer, okay? So you get, yeah, so you probably, let me just, you get 11x squared here, right? Then you get 54x and plus 63 equals 0. Yes? And then what do we do? Hello? Can you hear me?
I think we can factor the expression.
Right, you can. So this time you get a 111 there, right? 63 is 2 times 3 times 31, right?
21.
21, yes, 3 times. So maybe we do 3 here and we do 21 there, yes? So adding up to 54. So you get x minus 3, 11x minus 21 equal to 0. So you get x equal to 3, this is minus, or x equal to 21 over 11 minus. Now, fortunately, both are what? Both are solutions. Okay, so this time you check both are solutions. Okay. So you have 2 different way to change route. Okay. Do you all understand this this problem here?
Yes.
Yes.
Very good.
Yes.
Okay, I want to go back to section 2.3 where people having trouble to solve quadratic equations with letters. right? So that's the, so these are some problems from the, so this is number 53 in 2.3. So A equal to 2 pi times R plus H, then 2 pi R times this. Want to solve for R, right? And people did all kinds of things. You see, this is what people do, okay? R equal to A over 2 pi R plus H. Is this correct solution?
No, because there's still a leftover R in the denominator.
Or you do the other way around. Some people say, well, R equal to A over 2 pi R minus H. Is this correct?
No, you first need to do a quadratic equation with R.
So in the homework assignment, I did actually tell you what to do. You didn't. Okay, so you have to write this what? You cannot solve R in terms of R. Okay, R has to be solved in terms of nothing. The rest of the variables, not the R variable again. What you should do is you rewrite this as 2 pi R squared plus 2 pi R H minus A equal to 0. This way, you see you have a R here, R squared here, you have an R here. So it's a quadratic, right? So if it's a quadratic, then you can write this as a 2 pi H then times R minus A equal to 0. This tells you it's a quadratic equation with A equal to 2 pi. What is B? 2 pi H. C is negative A there, okay? Then when you solve this equation, you get R equal to 4 pi here, yes? That's A. That's a 2A. Then negative B, and plus or minus square root of B squared, which is 4 pi H quantity squared here. Minus 4AC, which is a plus 8 pi A there. Do you all agree? Yes?
Yes.
Yeah.
So therefore, the only way you can simplify is a 2 there, right? So you can simplify this as 2 pi here, it's a negative pi H plus or minus square root of, which is a pi square H square plus 2 pi A there. So you see that, well, you are solving the variable H or R here. So you have to write everything in terms of R as an equation, okay? Treating R as your X variable, and so that you can use quadratic formula to solve, okay? Do you all understand this solution then?
Yep.
Okay, so most people have no trouble, but I do see a few students don't know what, okay, have no idea what to do. The second example is this. Let's use the quadratic formula to factor the expression, which is number 48, which I ask people to do. That is 15x squared plus 34x minus 16. The reason that we don't want to factor just using the cross method here is because there are too many choices of A and C's, B and D's. So instead, we're going to, so we factor, right? Factor this, you set this equal to 0. Then you find the 0 first, right? So you get x equal to 30 here, negative 34 plus or minus square root of b squared minus 4ac, which is this 16 here. So 960, agree? So if you use your, if you do your work, so it's a 34 squared is, so it's going to be 165 and 11. So it's 1156 adding 960, you get 611 and 2 here, right? take the square root, 2116. So you get 4 here. So do I get a 6 there? Yeah, so it's gonna be 16. So we'll do a 4 here, which is 16, so 516. So it's 8, probably 6 here, right? Yeah, so it's 46. So therefore you get 46 is your square root, agree? And then after this, people just get lost. What do? You don't leave your answer like this. You have to simplify it. The first one is you get 12 over 30. Simplify that, you get 6 divided by 6. So you get 2 over 5, right? 2/5 is the first solution. The second solution is negative 80. Yeah, so it's gonna be what?
Negative 8/3.
Yeah, negative 8/3. I have these two zeros. Remember that you have zeros, you can rewrite this equation as what? So 15x squared plus 34x minus 16 equal to 15 times x minus the first zero times x minus the second zero, okay? And therefore you can have what? You can give a 5 factor for the first factor, give a 3 factor for the second one. So you get 5x minus 2, here's 3x plus 8. And this is the factoring, okay? And I see people just solve this, then do nothing else. You know that that's not the question. When you solve a problem, you need to read the question and answer the question, okay? All right, so that is all for today. And fortunately, we get it through. So next time, we're going to cover section 2.6, which is a very, very difficult section. Okay, most people will think that, oh yeah, it looks easy, but that's the hardest part conceptually. Okay, so you're going to preview the material first if you can. All right, and that's all for today. And if you have questions, you can stay here. We can discuss. If you don't, you can leave. Have a good day.
You too. Bye.
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 Bye,
Bye.
Dr. G.
But
Thank you.